Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question which is linked list cycle. And in this question we have been given the head of the linked list and we need to determine if the linked list has a cycle or not. And there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. So what is he saying is that if we follow a next pointer of each node and if we visit the node again, then there is a cycle. If you look at this example, if we start from 1 and we go to 2 and we again go to 1, then there is a cycle. So at the end, we just need to return true if there is a cycle in the linked list. Otherwise, we need to return false. So one more important thing is we will not be provided with this argument. We will only be given the head of the linked list. We will not be provided with the argument where the cycle will be, right? If they provide the argument, then it's very easy, right? If the position is greater than or equal to 0, then there is a cycle. If the position is -1, then there is no cycle. So they're not going to provide us the position argument. So we need to identify the cycle. So if you look at this example, there is a cycle, right? I'll start from here and we don't even need to traverse the entire linked list to say there is a cycle. We can directly say that there is a cycle, right? Here also there is a cycle and here there is no cycle, right? So let's solve more examples in order to get a better idea of this question. Now let's look at these two examples. In this example, if you look carefully, there is no cycle, right? So we'll just start from here and we just go and at the end we'll find null. So there is no cycle. If you look at this example, there is no null. There is no null in this linked list, but there is a cycle. So in the linked list where there is a cycle, there will be no null, right? So there cannot be two pointers from like this, from 3 there is also 4 and from 3 there is also a cycle. There cannot be two pointers. There can only be one pointer. So in this way we can say that if our linked list has null, then there is no cycle. If our linked list does not have any null, then there is cycle, but that doesn't work. So let's see how we can solve it. So it's very easy, right? So how am I able to identify circle means, first I'll start from here, then I'll go here, then I'll go here, then I'll go here. Look at them. I'm already marking them as I already wished it. Then I'll go here, then I'll go here, then I'll go here, and again from here I'm going here. But you see now, I have already marked it. So I have already wished it. So since I have already wished it, and I'm again wishing it, there is a cycle, right? So let's solve another example to get a clear idea, or let's solve this same example with a clear explanation. So, so what I'll do is I'll take a set. My set contains all the visited nodes, right? So if the current node is already in the set, that means it's already visited. When it's already visited, then there is a circle, right? So using this approach, let's try to solve this. I am right here at 1, right? So 1 is not in the set. So I haven't visited 1 yet. So I'll keep 1. I'll add 1 to the set and I'll move my pointer. When I come to 2, I'll check if 2 is already in the set or not. 2 is not in the set, so I'll add 2 and I will move to 3. Now I'll check if 3 is in the set or not. 3 is not in the set, right? So I'll add 3 and I'll move to 4. I'll move to 4. So I'll check if 4 is in the set or not. 4. Oh, I'm sorry. I already added 4. Now I'll come to 4 and I'll check if 4 is in the set or not. It is not in the set, right? So I will add 4 and I'll move to 5. I'll check if 5 is in the set or not. It's not, right? So I will add 5 and I'll move to 6. 6 is not in the set, right? So I'll add 6 and I'll go to 7. 7 is not in the set. So I will add 7 and from 7 I will move to 4. So this is the most important step. Now when I came to 4, I'll check if 4 is in the set or not. Yes, it is already in the set. So this means that there is a cycle. That's it, guys. Let's try to code this up. So basically what I'm doing is I'm using a set which stores the list node. Set equals to list on new hash set. Now I'll I'll keep a pointer pdr equals to head. Now I'll go till my pointer not equals to null. If set dot contains of pdr, if the set already contains this pointer, this node, then we just return there is a circle, right? Else I will add this current node to the set, and I will move my pointer pdr equals to pdr dot next. At the end, if there is no circle, I'll come outside, right? So I'll just return false. Let's try to run this. It's running fine, and it's getting accepted. But in the interview, let's look at the time complexity first. Time and space complexity. So what is the time complexity means? We will be visiting each and every node only once in our entire program, so it will be order of n. But what's the space complexity? We are storing n elements, right? We are storing each and every element of the linked list. So our space complexity is order of n. So you might say that what if it's something like this? Oh, it cannot be like this, right? The link must come from the last node. So we must and should store each and every node in the list. So the space complexity is order of n. But the interviewer might ask us to optimize the solution by using a constant memory. So basically here we are using order of n space. So the interviewer might ask us to optimize the solution by using order of one memory, which is constant memory, right? So let's see how we can do that. So in this case, we will be introduced to this algorithm, which is called Floyd cycle detection algorithm or tortoise and hare algorithm. So I'm not sure is it hare or not. So let's try to understand what is this algorithm. So this can be mapped to real life with an example like there is a person who is walking one step at a time, and there is a guy who is jogging in the park, and let's say this park is like this, a circular park. So this guy takes one step at a time, and this guy jogs, right? So he takes two steps at a time. So he takes one step and he takes two steps. He takes one step and he takes two steps. He takes one step and he takes two steps. Like this, it will go on. Well, one step, two steps, 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 and one step. And at some point, at some point, this guy who's doing the jogging will definitely meet the person who is walking, right? Definitely they will meet. They'll either meet or this guy crosses him, right? And in the either in the next round or the another next round, they will meet each other at any point. They can meet each other at any point, whether it can be here or it can be here, it can be here, it can be here, but they will definitely meet each other at one point. So using this idea, we're going to solve this linked list cycle detection problem. So let's see how are we going to solve this. So let's say this is the linked list we have, and here we have a cycle. So initially we'll have a guy who walks, right? Let's say a walker, and there is a guy who jogs. Let's say runner, RUNNER. So if you look carefully, from here to 4, there is no circle. So this is not the cycle. This is not the circle or cycle, whatever. So from here, the cycle starts. From here, the cycle starts, right? So this is the end, and again, this just keeps on rotating. So What we'll do is this walker walks one step at a time and this runner runs two steps at a time. So let's try to solve this. So initially, let's say the runner goes. The runner will come here and the walker will walk one step, right? The walker will come here. Again, in the next step, these two people haven't gone into the circle yet, so they cannot meet each other. If if it is a straight line, if it is a straight line, they cannot meet each other at any point because the walker will come slowly, but the runner will go, you know, like very far, right? They cannot meet each other. They can only meet each other when there is a circle. So now the runner will one, two, the runner will come here. The runner has already entered into the circle, but the walker he's not even in the cycle. So the walker will come here. And again in the next step the runner will one, two, the runner will come here. The walker will just enter the circle just now, right? So again in the next step the walker will one, two, the walker will come here. Oh, I'm sorry, he's the runner, right? He's the runner, and the walker will come here. And in the next step, the runner will move. Oh, I'm sorry. The runner will one, two. The runner will come here. We cannot say they met at this point, right? Because when the runner is coming here, the walker also moves one step, right? So the walker will be. Oh, I'm sorry. The walker will be here at this point. So again, in the next step, they will definitely meet with each other. In the next step, the runner will be here, and the walker will also be in the next step. So, as I have already said, when they are moving inside a circle, they'll definitely meet each other. Definitely meet each other. That's it. So, what if we don't have any circle? What if we have something like, I'll take an example. So now let's take a look at these examples. These two examples does not have any circle. So, I mean cycle. So let's try to understand how these work. So So the runner will move two steps, right? One, two. The runner will come here, and the walker will come here. And one, two. The runner will come here, and the walker will come here, right? So if you observe carefully, the runner has reached a point where the next node is null, right? So let's also look at this example in order to get a clear idea. So the runner will come two steps. So the runner will be here, and the walker will be here. In the next step, the runner will come one, two to here, and the walker will come to here. So if you observe carefully, when there is no circle, the runner is the one who reaches the null first, right? So if the runner reaches to the null or to the previous node of the null, then there is no circle, no cycle or circle, cycle, whatever. So the runner is the one who goes to the null first. So using this using this idea, let's try to code this up. So let's try to code this up. We have two pointers, right? This node, the one who is runner is also head, and walker is also head, right? Initially, I need to check if runner is not equal to null because runner is the one who reaches the null. If there is no cycle, runner is the one who reaches null first, right? So runner should not equal to next, and not runner dot next should also be not equal to null, right? Now runner moves two steps. Runner dot next, but the walker moves only one step, right? So if my runner and walker meet at the same point, then there is a circle. At the end, if these two guys haven't met each other and runner came to null, so we can say that there is no circle, right? So we can just return false. Try to submit it. So this approach, I know this approach like fast and slow pointer, but this intuition I got it from one of the solutions tab. We can always go through these in order to identify different ideas of how other people are thinking. I think this does make sense, right? This is very easy to understand, and you know, it makes sense. So that's it, guys, for this video. And if you find the video helpful, just give a thumbs up. I'm sorry, I mean, like the video. Thank you.